There's all kinds of stuff going on in this section. Now, when you turn in your books to do the homework, you turn to that homework page. What are we on, 1-5? But what's in front of what are on the pages before the homework? Do you know what is actually on those pages? Anything more? Confused. You're confused. So when you open up your book to do the homework, there's problems down. What's on the pages before the problems?
Examples.
Examples. There are. And do you know what you guys can do? You can actually look at the examples to help you learn. Did you know that?
No.
You didn't?
I
Kind of did. Well, we're going to try to prod you to do a little bit of that with this section. But there are example problems in the book. I don't know if some of you knew that. And you can look at those example problems. When you get stuck on a problem, you can go in the book and look. And there's other things too. But there's also in front of each section, there's nice little intros where they talk about different things and different people. You know, look, who's that right there? Albert Einstein's on one of them. Okay, you might want to learn a little bit about Albert. Okay, who else? What else we got here? So, you know, you can learn a lot from just reading your book. Oh, we got the alternating current circuits. So, you know, a lot going on. So we're going to have you do a little bit of that later on, and I'll show you what I mean by that. So I'm not going to go through these in class. You're going to use the examples in the book to learn how to do these because you've had them before, and I don't think it's too bad. I'm going to go over the ones I think you need a little bit of extra help on. But I want you to be able to use your book as a resource, not just a list of problems. All right, I do want to go over these because they can cause issues. So go ahead and copy that down. For that. Let me see if I'm actually recording. Okay, we're good. I like to get rid of equations, get rid of the fractions by multiplying by the least common denominator. Anytime you have a unique expression, you need to put that in as part of your common denominator. So right here, my least common denominator would be x plus 1 times x plus 2. I mean, in theory, you can get that, use that, but I just use it to wipe everything out. I am going to multiply each piece by that. So we have x over x plus 1. I'm just going to rewrite it and spread it out a little bit here. Plus x plus 1 over x plus 2 equals 1. As long as you multiply every piece by the same thing, you don't change the value of the equation. The left side is still going to be equal to the right side. So I'm going to multiply everything by x plus 1 times x plus 2. Including the 1. Even though it's not a fraction, you still have to multiply everything by that least common denominator. Okay. What does that do? How does that help us? When we do that, it gets rid of the denominator. They cancel out. So this x plus 1 cancels with that x plus 1, and you have x times x plus 2 plus this x plus 2 cancels with that x plus 2. We have x plus 1 times x plus 1. And then over here, you just have x plus 1 times x plus 1. All right, now we just got this big mess. Distribute and FOIL where you can. Go ahead and do that. Distribute and FOIL. Don't go rogue on me. Okay. You want to cancel that stuff. We don't need that stuff in the denominator. And then I just pause for a second after you get combined like terms. So I got x times x plus 2, which is x squared plus 2x. All right, when I FOIL, I'm going to write it all out for the first one. X squared plus x plus 1. This gives me x squared plus 2x plus x plus 2. All right, I'm going to combine everything on the left. 2x squared, 2x plus x is 4x plus 1 equals x squared plus 3x plus 2. All right. Maggie, where do you think am I good? Is that right? We agree?
You forgot to make the 2x squared.
Ah, there we go. See, that's my check. Perfect. Now I'm all right? All right, where do we go from here? There can be confusion at this point. Where do I go from here? Or what do you want to do from here? All right, at this point, as we go through here. Lane, what do you think?
I mean,
What's your ideas?
both sides are trinomials. But I don't know if that's, you want to factor both sides.
No, don't want to do that. No, don't want to do that. All right, here's the first thing you got to analyze is will this end up being a quadratic equation or will it end up being a linear? Basically, will my x squareds drop out by adding up to 0? Will my x squareds drop out? No, so you're going to have a quadratic. So we just spent this whole last section solving quadratics by factoring, by completing a square, and by a quadratic formula, right? So we're going to have so typically your first thing you want to do is I'm going to have a quadratic, set it equal to 0. I would do that first. So I'm going to move everything on the right-hand side over to the left-hand side. Okay, so 2x squared minus x squared is x squared plus x minus 1 equals 0. All right, you got factoring, completing a square quadratic form. I'm going to try factoring first. I'm probably only completing the square if I'm told I have to. I'm probably going to quadratic form. Well, does that factor? Can you come up with two numbers that multiply to -1 and add to 1? No. We can't stop though. You can't say this. So we got to do what? Quadratic formula. Got to do it. Okay, you got no choice because it said to solve. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. And a is 1, b is 1, c is -1. Opposite of 1 is -1 plus or minus 1 squared minus 4 times 1 times -1 over 2. Emily, let me know what you get underneath the radical.
Except it's 5.
Looks like it's just fine. Can I do anything else with that? I got x equals -1 plus or minus square root of 5 over 2. Okay. Can I do anything else? No. Okay, there's your answer. On now, since we've dealt with all the quadratics, you got to take a look at any equation. Will it become a quadratic or stay a quadratic, or will those x squareds disappear and just become a linear? So you'll solve it different ways based upon that. All right, so we got rid of the fraction, went from there. All right, we're going to start this one. I'm not going to finish it. Oh, I needed to go back. I forgot to say something here. What can't x be as your answer? X cannot be anything that makes the denominator 0. So you got to take a look. X cannot equal -1, and x cannot equal -2. Well, hindsight, I already know that you don't equal that, but you need to know that ahead of time. So if you would get one of those answers, you'd have to throw it out. Okay, Aubrey?
For when you get the answer, is it fine to just leave it as that, or do you want us to put the -1 plus square root of 5 over 2, -1 minus square root of 5?
I know the book does that a lot. This is fine. I really don't care either way. They're equivalent. Okay. All right, now let's take a look at this one here. we'll set it up and kind of get it started. But I don't want to, I probably won't finish it. All right, one thing you need to do or you want to do to make it a little bit easier is on your denominators, you really only need denominators, factor anything that can be factored. Okay, and that one on the right will factor. So I got x over x minus 3 plus 3 over x plus 3 equals 6x. And that's the difference of squares. So I factor in x minus 3 times x plus 3. Now, my least common denominator, every unique expression is part of it. So it's going to be x minus 3, it's going to be x plus 3. You don't need to list them again. So they show up again, you just need to list each one once. Now, x cannot equal 3, x cannot equal negative 3. If you get any one of those answers, you throw it out. All right, I'm just going to set it up, or this next step. What do I multiply everything by? Madison listed, what do I multiply everything by?
X minus 3, x plus 3.
Good. Multiply it by that least common denominator. So I get x minus 3, x plus 3. X minus 3, x plus 3. And what happens, your x minus 3's cancel. X times x plus 3. I didn't write it here. X minus 3, x plus 3. X plus 3 is cancel. Plus 3 times x minus 3 equals, and everything cancels there, so it just equals 6x. All right, for that. All right, I'm stopping there. I'm stopping there. So you can just finish that later. Okay, so we got the basic idea. That's, to me, that's the hard part done. You know how to solve it from there. For that. All right, so that's when you got a rational. You got to get rid of fractions, find your least common denominator. We want to do that. Now just pay attention to this because it's going to come up. Principle of powers. Now, it should make sense if A equals B. If you square both sides, if you cube both sides, you take both sides to the fourth power. It's still got to be equal. But here's the thing that comes out is when solving this using the principle of powers, you must always check for what we call extraneous solutions. Extraneous solutions are solutions that work for the modified equation, but not the original equation. Quick demo. 2x equals 6, right? X has to equal what? 3. If I square both sides, I get 4x squared equals 36. I divide by 4, I get x squared equals 9. Well, take the square root of both sides, you get plus or minus 3. Well, negative 3 will work here. 2 times negative 3 is negative 6. Square it, you get 36. But can negative 3 work over here? No. So when you square both sides, you could potentially add a solution that doesn't work. You must check that. Okay, you must check that. All right, let's take a look at where this comes into play. All right, we will do this. Okay, we will do this one. All right, if it has one radical, we want to get rid of that radical. And to get rid of that radical is that's where we square both sides. So when we square both sides, we throw into that situation where we could add a solution that doesn't work, an extraneous solution. When you square both sides, okay, you get the square root of 3x minus 2 squared equals 5 squared. All right, well, what's the square root of 3x minus 2 squared? That is just 3x minus 2. 5 squared is 25. Add 2. 3x equals 27. Divide by 3. X equals 9. All right, you have to check it. If you check it and it doesn't work, then potentially you made a mistake. But potentially it's an extraneous solution. Well, this one's an easy one. 3 times 9 is 27. 27 minus 2 is 25. Square root of that is 9. That's 5, or is 5. So it does work. All right, I'm not going to go through the second one. I do want to, you can just make this one number 2. Solve that one. Solve square root of 3x plus 1. That plus 1 is not underneath the radical. Equals y. All right, now, before you square, you want to isolate the radical. Isolate the radical first. Subtract 1. Okay, when you square both sides, you have to kind of treat, like put parentheses around each side. You cannot square individual terms. You kind of have to do an umbrella. You put an umbrella around the left side, you put a big umbrella around the right-hand side. Okay. Okay. Now, what that means is you put square root of 3y plus 1 quantity squared. You must put everything on that side in parentheses, and you square it. So what do we actually have to do on the right-hand side? Got to FOIL it. If you just square those individual terms, that doesn't work. You have to FOIL it. And that's probably going to be the biggest mistake, is people just want to do squared and squared. That does not work. That does not work. So right here, this is 3y plus 1 equals, all right, that gives me y squared minus 2y plus 1 when you're done. When we're done. All right, is that going to be a quadratic? Yep. Set it equal to 0. Move whatever's on the left to the right. So subtract 3y, subtract 1. I get 0 equals y squared minus 5y. Okay. And all right, now this one, you want to make it harder than it is. This is not a trinomial, but this is factorable. What can we factor out? Y. Take out GCF. So 0 equals y times y minus 5. That means y equals 0. That means y equals positive 5. You got to check. So if you're sitting beside somebody, one of you check 0, one of you check 5, you need to at least check one of those answers. Plug it in, go all the way back to the original problem. All the way back. Are you just checking both?
Yeah, well, do you want to check one?
I'll check 5.
Hey, was there no rotation on the left side? Just
Yeah, 5 works. 5 works. I did this radical 16. Plus square root of 16. 4 plus 5. Alright, really? Adam Lippy, did they both work?
Y equals 0 does not work.
Y equals 0 clearly does not work. So I still need to see those answers. You still need, then you indicate that one doesn't work, and you make sure I understand. You tell me which one does work. Okay, so y equals 5, y equals 0 is extraneous. You don't need to write down extraneous, but you need to show me that it doesn't work. Okay, and so y equals 5 is our only answer. You plug in 0. 0 plus 1 is square root of 1 is 1. You get 1. You get 2 equals 0. Doesn't work. All right. Now we're going to do one more together. You need a lot of room. So if you're at the end of the half, you need more than a half a sheet. Okay, this is a good one or a bad one. I know how you look. And don't get ahead of me. I suggest. All right, we have 2 radicals. Now this just kind of mucks everything up. If we have one radical, we isolate the radical, we square both sides. Now we got two. You can't, just simply isolate it. What you want to do is at least get one radical isolated. Get one of them isolated. So I'm going to subtract this one, square root of 3x plus 4 minus square root of 3x plus 4. All right, so I get the square root of x plus 2 equals 2 minus square root of 3x plus 4. All right, once you have at least one of them isolated, go ahead and square both sides, but you got to follow that procedure where you put a parentheses around the entire side. So I got the square root of x plus 2 squared equals, 2 minus the square root of 3x plus 4 quantity squared. All right, left-hand side is not a big deal. That just becomes x plus 2. But what do I have to do on this right-hand side? You got to what? You got to FOIL. You got to FOIL. I'm going to do it over here on the side just to save a little bit of room. So, and I'm going to go through it. Okay, so I got 2 minus square root of, that's 3x plus, hold on here. Okay, so when I do FOIL, 2 times 2 is 4. 2 times negative square root of 3x plus 4 is minus 2 square root of 3x plus 4. Minus 2 square root of 3x plus 4. And now I get a negative times a negative is a positive, but what does that become? Just what? 3x plus 4. So the radicals drop out. Okay. So I'm just going to go over here and write that. That's going to be 4 minus 4 square root of 3x plus 4 plus 3x plus 4. All right, what can I do from here? I used to have 2 radicals. What do I have now? 1 radical. So I go back to my old rules. The 1 radical said we'll do what? Isolate it. We got to isolate that radical. We got to get it by itself. Now I'm going to combine like terms and I'm going to move everything. But I'm going to move everything over but that radical eventually. So I got x plus 2 equals 4 plus 4 is 8 plus 3x minus 4 square root of 3x plus 4. I'm going to subtract 8. I'm going to subtract 3x. And so I get negative 2x minus 6 equals negative 4 square root of 3x plus 4. All right, now you do have a couple of options here. This negative 4. We can do it right now, but we can also get rid of that negative 4. What would we do to get rid of the negative 4? Divide. Don't do it. Just hold on. I'm not going to do it, but because here's why I'm not going to do that. If I divide by negative 4, I got to divide everything by negative 4, and it gives me 1/2 x plus 3/2 equals that. There's nothing wrong with that, but I don't want to work with fractions. So I would choose not to do that. If this was a 2 right there, that would give me what? X plus 3? Then I would do it. But if it's going to give me something that's harder to work with, I'm not. So I can square it right here. So I'm going to square both sides. I put parentheses around the whole thing. And I'm going to do the same thing here. This will be a FOIL. This will not because there's no plus in between that 4. And I am going to write them out twice just for this one. Now, I wouldn't expect you to do it in a homework or on a test. And that's going to be negative 4 square root of 3x plus 4 times negative 4 square root of 3x plus 4. All right, go ahead and FOIL on that left side. Everything will come back positive because everything you're multiplying together is negative. All right, now let's see what we get here. I got 4x squared. I got a negative 12 and negative 12, or positive 12 and positive 12 is plus 24x. I got plus 36. All right, here's what's going on here. This is just a constant out in front. Negative 4 times negative 4 is 16. But now square root of 3x plus 4 times square root of 3x plus 4 is just 3x plus 4, but you got to treat it as in parentheses because that 16 needs to distribute. Okay. So I got, I'm going to distribute. I got a 4x squared plus 24x plus 36 equals 48x plus, what is it, 64? All right, so you got to be able to analyze that and say, all right, what do I do from here? You have an x squared. You can't get rid of it. You want to set it equal to 0. Move the 48x over. Move the 64 over. Minus 48x. Minus 64. And then I get 4x squared minus 24x. 46, 50, 28, right? Minus 28. Okay, what can we do from here? It's a quadratic. You can factor it, you can complete the square, you can use the formula. What you got?
Pull out a 4 first.
Pull out a 4. Anytime you got GCF, pull out a 4. X squared minus 6x minus 7. That does factor. X minus 7 times x plus 1. Now, since the 4 doesn't have a variable, it doesn't give you another answer. It doesn't give you an answer 0. But x minus 7 does give you x equals 7. And x plus 1 gives you an answer of negative 1. Go back up and test them. Well, I get 7. See what it gives you. Well, I get negative 1. See what it gives you. You still have to do that because we squared both sides. And it can just be a mental check. Okay. You know, if it's not too complicated of a problem. So what do we have? Negative 1 and 7. Oh, 7 plus 2 is 9. Square root of 9 is 3. 25. I got 8 equals 2 for 7. I don't think that works. So 7 throws out. And how about negative 1? Does that work? Should work. So I throw the 7 out. Make sure you identify that the negative 1 is a problem. Okay. All right, pull your books out. Turn to page 140. Turn to page 140. That's where all the problems are. Now, before that, those other special pages that have examples on there. So here's just kind of a breakdown. So there's the assignment, 9:15. So if you get stuck, if you're not sure, so for 9 and 15, you can go to examples 1 and 2 on page 131. 21 and 25 and examples 3 and 4. $55 is similar to what we just, that last one we did. And we went through a couple of them. And you might be fine. But if not, I want you to look those up. Now you can work, I want you to work until the end of the period or you're done. You know, if you want to talk with whoever you're sitting by, that's fine. I mean, obviously, you know, you want to stay in your seat, you have to stay in your seat. But if you want to communicate, say, hey, what'd you do or how'd you get this? That's absolutely fine. All right, here's kind of the outline of what we're doing. I'm just going to talk while you're working. 1-5 today. We're going to do 1-6 Thursday and 1-7 Friday. That's the end of chapter 1. We'll review on Monday. We'll test next Tuesday. So we're on target for that. I will caution you. I will caution you for tests. And it didn't really come up because you had plenty of time on that first quiz, but tests is a different story. There's a lot of material and the tests are lengthy. What you need to do is you need to finish the test and then go back and check your answers. You know, do not do number one, check it, see if it's right, then go to number two. You'll run out of time, some of you. So you finish the test, then you go back. You get stuck on a problem, you do not sit there for 20 minutes on one problem. Okay, there's no extra time. If you don't get done, they get counted wrong. It's like the ACT. Okay, now if we got a situation where 70% of the class doesn't get done with it, then that's my fault. Then I will give everybody extra time. But so you got to be careful. You got to be able to pace yourself. Pace yourself, and make sure you check the odds in the back to see if you are correct.